refraction of wave. So what is refraction of wave? Right? Refraction of wave is changing of speed of the wave when the wave propagate into different of that. Or sometimes, right, different of that. Sometimes we can call it a different medium. If light, we use different medium. If light, we use different medium. Due to change in speed, not velocity, speed, speed of the wave. Speed of the wave. Where frequency remain unchanged. Changing of the speed of the wave when the wave propagates into the different depth of water due to the change in the speed of the wave. Where the frequency, no change. Where the frequency, no change. We are going to see reflection. After the reflection, frequency remain the same. After the reflection, speed of the wave change. Speed of the wave will change, right? Depend on you go deep or you go shallow. If the wave enter the deep region, right, the speed increase. If the wave enter shallow region, the speed reduce. Mean the water, the wave go to the deep water, the speed will be faster. The water will be faster. And if it go to shallow water, right, the speed of the wave will be slower. And then we look at the next one. Is wavelength. Wavelength will change also. Wavelength also change. Wavelength also change, right? When it go to deep region, the lambda increase. When it go to deeper area, right, the lambda getting more. If we go to shallow area, the lambda getting smaller. If you go to shallow water, the lambda getting smaller. Lastly, direction of propagation. Direction of propagation of wave, right? I use the word of can change. But in fact, if you see your book, all use change. I'll tell you why I use the word of can change. All right, I do it here. This is a piece of glass. The light come into here. The light come into here. And the one that it enter, we call it as normal line. This one is called normal line. This one is incident wave. Incident light, incident ray. incident wave, right? And then this one is called normal line. Normal is always 90 degrees to the surface, remember? Right, I gave you before. When the light enters from less than from the A to the glass, right? Mean less than to denser, less than to denser. So what will happen? We are going to see. So this light will be bent toward the normal. It will bend down this way. So when the light entering from less than to denser medium, you bend toward normal. The light will bend toward normal. All right. When the light go out from the glass to the A, from the glass is denser. This is less than. So from denser to less than, so we are going to see what happens. So through the experiment, this is the normal. This is the normal line. And the light will come into this way. You bend away from normal. You will not go straight. You bend away from normal. So bend away from normal. This is the incident wave, whereas this one is refracted wave. This is a reflected wave. All right. Let me explain to you what is refraction. Refraction of wave is the wave come here, it is fast, and then it enter this medium, the glass, and enter the different medium. So you bend toward or away from normal, right? Because it changed in speed. Changing of speed of the wave when the wave go into the different medium because change in the speed. Where the frequency, no change. Where the frequency, no change. And if I use refraction, I normally use 3 guy running, right? I think it is easier, but I will do both for you. You'll see, right? After I do 2-3 times, then you tell me, I don't want. I want to use 3 guy running. All right, so this is deep region. This is shallow region. From deep to shallow. The wave coming into here, the wave direction is always 90 degrees, I told you, right? I want to complete the drawing of the reflected wave. Okay, this is deep. Deep mean fast. Shallow mean, right? Jetek, shallow mean jetek. Jetek, slow, right? So the wave come to here, 1, 2, and 3. I said 3 guys. I got B, I got C. 3 guys running. A come to here, B come to here, C come to here. They come with the same trick. A come to here, B come to here, C should be come to here. Should be in this speed, this row, right? But shallow, slow. I can explain it by using this way. If you enter the shallow area, like you go into a lot of sand, right? When you want to run at the sandy area, right? So hard for you to run. So you cannot run fast. You will run slow. So slow, you reach nearer or further. Nearer or further. Because slow. This guy reach here, this guy reach here, this guy reach here, this guy reach here, this guy reach here. This guy cannot reach here because it is slower. Right, nearer. So it will reach here. So I join this line, this point, this is a line. come to here. It's black color. This line come to here, then join to here. Right. Same as this. A come to here. B go in. It's supposed to come to here. But because of the enter, hard to run, it will run nearer. And then this one is slower. 1, 2, 3. Right. I join them together. This is the direction of propagation, must be 90 degrees. I told you must be 90 degrees. Now I want to draw. If I draw like that, it is not 90 degrees. So I need to draw something. You see the direction of the wave change. 90 degrees, yeah? The direction change or not? Yes, the direction change. The direction of propagation change. Right? And see, the wavelength here big. Wavelength at the deep region, the wavelength is big. When it go to shallow area, the lambda getting smaller. Lambda getting smaller. The lambda will not getting bigger. Right? Lambda getting smaller. Because why? Because the speed change. Speed getting slower. Speed getting slower. Is that okay? Direction change, yeah? Right?